Today we'll be discussing about the metallurgy. So in the metallurgy, if you take the extraction of aluminium, it also contains the electrolysis part. So therefore, yesterday, if you understood electrolysis better, then that part will become very easy for you. But yes, there are some fixed kind of questions in this particular chapter, especially the concentration methods, which ore will be used, or which ore will be concentrated by which method, or what is the difference between calcination and roasting. In the reduction process we have some questions, as well as extraction of aluminium. There will be 2 to 3 marks, and alloys part, again there will be 2 to 3 marks, usually 2 marks will be there. So metallurgy, fixed kind of questions, and go and check the previous year questions which I'm going to upload. You'll come to know the repetitions. Fine. So let's start with the metallurgy. So what is metallurgy? There is some compound, and in that compound you have a desired element in it, okay, metal in it, and you want to get that metal. We call it as extraction of a metal, that too in its pure state, means it should not have any kind of impurities. In this process there will be lots of different stages involved. Therefore this whole process will be called as metallurgy. Okay, first of all let's understand the difference between minerals and ores. Many of you think both are same. Actually both are same, but there is one difference between them. What are minerals? Minerals are the naturally occurring compounds of metals which are generally mixed with other substances, which we call as impurities. Okay, which we call as impurities. But what about the ores? Ores are those minerals from which metals are extracted commercially at a comparatively lower cost and with minimum effort. So basically, all the ores are minerals. All ores are minerals. But you can't say all minerals are ores. Okay. Say for example, aluminium has different kinds of ores. Bauxite is there. Okay. Then there is a fluorspar, not fluorspar. Cryolite is there, right? And there is alumina, anhydrous Al2O3. So out of these, through which ore, through which mineral you can extract aluminium with less effort? Yes, and with less amount of money. Lower cost means what? Less amount of money. So we do that with bauxite. Therefore, we can say bauxite is the ore of aluminium. But cryolite and alumina can also be used. I'm just giving you example. Okay. Huh. Uh, we have some ores of three elements: aluminium, zinc, and iron. We need to know their formulas. Anyway, for aluminium, we know already aluminium bauxite, aluminium oxide dihydrate, cryolite Na3Al(F6), anhydrous aluminium oxide, which is called as corundum Al2O3. Okay, so you can say when you concentrate the bauxite, or what you're getting, anhydrous aluminium oxide, right? So that is nothing but corundum, but sometimes it may be available naturally also. That will be called as corundum. Coming to iron, don't worry about red or brown hematite. Just remember the main ore of iron is hematite. It is ferric oxide, hydrated ferric oxide. Okay. Then other different kinds of ores are triferric tetroxide, which is magnetite, iron pyrite. Iron pyrite we use in contact process to get SO2 gas. If you remember, FeS2 plus O2 gives you Fe2O3 plus SO2. Siderite, ferrous carbonate. Hematite, magnetite, iron pyrite, siderite. See, that depends on the question paper. Sometimes they may give you, any question from the any part of the paper book. Therefore, we should know. If you are able to remember, okay. Otherwise, at least remember the main ore. So here you can see the main ore used for the extraction of iron. That will be hematite, right? Hematite is a chief ore of aluminium. Okay. So, Iona, can you tell me what we have to change here? It's iron. Yes, you can change this part as iron. But if you don't want to change, but you want to change the hematite ore and you write bauxite here, then also it is correct. Bauxite is the chief ore of aluminium or hematite is the chief ore of iron. ठीक है ना? Coming to the ores of zinc. The main ore of zinc is zinc sulfide, which you call a zinc blende. Then comes zincite, ZnO. Zincite is a zinc oxide. Calamine is zinc carbonate, ZnCO3. Okay. The main ore of zinc is zinc sulfide. Name the following. Ruhani, first one.
Zinc sulfide. Zinc blend.
Yeah. Zinc sulfide is also correct. Zinc blende is also correct. Okay. The most commonly used oxide ore of aluminium. Tanisha?
Bauxite.
Correct. Bauxite. Okay. Coming to the next part, that is different stages of metallurgy. Different stages of metallurgy. Okay. So first stage, you will get the ore, or you may be having different minerals of a particular metal. Out of that, you will choose one ore. Stage 1 will be crushing and grinding. Okay. Then crushing and grinding means you will make it into powder. So converting the ore particles into fine powder, you can also call it as what? That process as pulverization. What is pulverization? Converting the ore into fine particles. Yeah. Coming to second stage, concentration. Okay. In concentration, what we do? Concentration has different names. It can be also called as dressing of the ore. Okay. Or purification of the ore. All are same. Mainly what we do here in this stage, removal of impurities. These are nothing but what you learned in lower grades, separation techniques, right? Removing the impurities from the main substance. Here we have different methods of concentration: gravity separation, froth flotation, magnetic separation, chemical method, or leaching. We will see one by one. Okay. After you remove the impurities, next stage will be roasting or calcination. When we do roasting or calcination, we will see that. Basically, we want to convert the ore into metal oxide, right? So the ore we will convert into metal oxide, in which case roasting and calcination stage. Next, reduction. So from the metal oxide, you have to remove the oxygen. Removal of oxygen will give you the metal. So that stage will be called as reduction. Now, whatever you get metal here, that we call as crude metal, means it might have some kind of impurities, other impurities which you are not able to remove in concentration stage. Then what we do, go to the last stage, that is refining. Whatever that small impurities, maybe 99.8% metal is pure, but 0.2% some impurities there. That 0.2% will be removed in the refining stage. Finally, what we get? Yeah, we do use electro refining for that. Okay. Finally, we get the pure metal. See, all of you join at 10 o'clock. If you keep on joining late, you are disturbing the class as well as you are missing initial parts. Okay, 10 o'clock means 10 o'clock. Chalo, let's take different concentration methods. So, concentration methods. First method is hydraulic washing. It has different names: hydraulic washing, gravity separation, or levitation. Focus on the principle here. Mainly, there will be one heavier particles or more denser ore particles will be there, less denser gangue particles will be there. Then what we do, we take this kind of arrangement where this whole table, we call it as a vibrating corrugated table. Means that table will be continuously vibrating, and you can see it has some kind of troughs here. From here, you will put initially the finely powdered ore particles in here. Then spray of water will be passed over here. The heavier ore particles will settle in these kind of troughs, but the lighter particles, which are impurities, gangue particles, they will be gone with water and they will be collected separately in another container. Simple technique. Okay. What kind of one example we have to remember: oxide ores of iron and tin are concentrated by this method. Okay, like iron oxide, Fe2 or Fe2O3, or tin oxide, SnO2, those will be concentrated by gravity separation. Magnetic separation, this one we have learnt in lower grade. So out of the impurity and the ore, one will be magnetic, another will be non-magnetic. Then what they do, they will have these big giant wheels. Okay, out of these two, this wheel will be magnetic in nature. So from top you can see the powdered ore is coming, and this will be keep on rotating. There will be a belt which will be keep on rotating. Okay, like this. Then whichever is magnetic substance, that will stick to this wheel and it will form a separate heap, and which is non-magnetic, that will fall here only. So by using these giant wheels, they separate the magnetic and non-magnetic things, and this you can use only when there is one of them will be magnetic and another one will be non-magnetic. Example you can see here. This method is used to concentrate tin stone. Tin stone is nothing but tin oxide only, SnO2. Okay, it contains the impurity which is magnetic oxide of iron, which you call as magnetite also, triferric tetroxide. This will be the impurity which is removed. One example you have to remember which ore is concentrated by which method. Okay, Chanvi, can you tell me the answer for this?
So it's the hydraulic method.
Gang by preferential wetting.
Froth flotation.
Hmm. Froth flotation. So this is the next stage, next method. Froth flotation method. Okay. So see here, froth flotation, the principle here is, this is mainly done for sulfide ore concentration. In this, we use two different kinds of uh, solvents, you can say, or liquids. One will be water, another one will be oil. Oil may be pine oil or some other thing. So what happens in these kind of ores where the sulfide ore is there, gangue particles will have more affinity towards water. More affinity means more attraction towards water, whereas the sulfide ore has more attraction towards the oil. So in this, say, and we know that oil and water will not mix. right? So here your sulfide ore will be there in the oil layer. In the bottom, because water is heavier, there we will have gangue particles here settling down. Then what they do, you can see in this image, there is one a hollow pipe here. Okay, this will be very big because they are doing this in industries, and it has some holes at the bottom. Here they will pass air. Then they will also add some kind of frothing agent, okay, which can form the froth. And when the air is bubbled through it, what happens? The froth will come up. Along with the froth, what comes out? The sulfide ore. So that will be collected separately here in another container. Only the froth will be removed and then collected it, and then they will remove that froth and get the sulfide ore. Okay. So this method is called as preferentially or preferential wettability of the ore with the oil and the gangue particles with water.
So do you have to know the diagram like immediately?
No, they will not ask you to draw the diagram, but they may give you the diagram and miss means something. They may ask you to write what is this. Usually they have not asked anything about concentration methods. Only for the preparation part will be asked, like in study of compounds. Okay. Sulfide ores like zinc sulfide, galena. Galena is what? Lead sulfide. Okay, are lighter than impurity present. They are concentrated by froth flotation process. Again, what confusion you people have whenever they ask you concentration method, you might write roasting. Hmm? But roasting is not a concentration method. Still, we use it for sulfide ore. That's a chemical process, na? Converting sulfide into oxide. So therefore, you have to read the question carefully. Concentration method is froth flotation. Okay, conversion into oxide, you will use roasting. Remember that. Lastly, chemical method. The chemical method or leaching, this is the one which we use to extract aluminium from bauxite ore, where this is nothing but you are simply making some precipitate. Okay, you are using some reagent like we studied in analytical chemistry, right? Sodium hydroxide we used, or ammonium hydroxide solution we used, and we got different kinds of precipitates there. So here also similar kind of thing. Here you can use some acid, some base, or some other reagent which can form a precipitate with a given ore. And then one will be precipitate, and say impurities are soluble, or it may be ore when it reacts with the some substance forms a soluble substance, soluble salt, and the impurities may be insoluble. In both the cases, we can separate them easily by doing filtration. Yes. So impurities will be separated. Your your ore particles will be separated. The leaching method is used for the concentration of metals like silver, gold, aluminium. So aluminium we are going to learn in detail.
What's your biggest process here?
One by one. Dhanesh.
It's your biggest process, right?
Huh? Huh. Bayes process. Okay, now what we got out of all this concentration method, assume that we got pure ore. Okay, that pure ore we have to convert into metal oxide. Convert to metal oxide. This stage comes only after concentration. Okay, so we have to take here concentrated ore. Before that, we don't do this. Okay, we have to remove the impurities. Here we have two things, roasting and calcination. Roasting, it requires, in both the cases, what we do, we take the ore and heat it to very high temperature. Only difference here is roasting, you need plenty of oxygen or the air. Calcination, you do it in absence of air, or you can say limited supply of air. Even if they give you limited supply of air, then also it is calcination only. Okay, fine. So what kind of ores are done roasting? Sulfide ore. What kinds of ores are done calcination? carbonate. So R in the roasting, S you remember, S for sulfide ore. In the calcination, Ca you remember, Ca for carbonate. If you're having confusion which ore for which method, then you remember this simple technique. Okay, so here you can see sulfide ore, zinc sulfide. When you oxidize with oxygen or heat it with oxygen, you will get zinc oxide and SO2 gas. But carbonates already have oxygen in them. Therefore, you don't need require extra oxygen. We simply heat. They undergo thermal decomposition, give zinc oxide, CO2 gas. Okay. Last part is fine. Volatile impurities are removed as oxides and the ore becomes porous and more reactive. Moisture and organic impurities are removed and the ore becomes porous and more reactive. Porous means it will start having the pores, means holes. Okay, na? So at least first part is enough. In excess of air, in absence of air, but in both the cases, what you have to do, you have to heat it to a very high temperature. Okay. Iona, can you answer this question?
Yes, can you hear me?
Yeah.
Heating in oil and then oh, absence of air is calcination.
Right. Below, you can see some extra information they have given here. In absence of air at temperature just below its melting point. Okay, if it starts melting, then the reaction will not happen. Select the process from the following matches the given description. Okay, Dhruva, what is the first one?
So polarization.
Pulverization. Yes. Rishi, what is the second one?
Calcination.
Very good. Fill in the blanks again. Vanishika, can you tell the answer for first one?
Yes, so usually carbonate ores are subjected to roasting, which is done in the absence of air.
Absence of air matlab you can't use roasting, no? Hmm.
Calcination.
Which ore? Calcination clay, which ore you will use?
Carbonate.
Carbonate or calcination, which is done in the absence of air. But if they given here reverse in presence of air, in excess of air, then your answer will be correct. Okay. Ruhani, B part.
Zinc blend is converted to oxide by roasting process.
Very good. Next, Darshwana, C part.
Froth flotation process is generally used to concentrate sulfide ores.
Hmm. So that's why roasting is to convert to oxide, whereas froth flotation is a concentration method, and both are done for the sulfide ore only. Huh. Come to the next and important stage. Once you got the metal oxide, you have to reduce it to metal. So reduction stage. Now in the reduction stage, lot of information is there, but let's try to make it easy. Usually what we use, commonly we use some reducing agents. Some reducing agents. In this case, they have given for us is hydrogen gas or coke, a form of carbon, or carbon monoxide. These are the common reducing agents we can use. But we don't use it in all the cases. Okay. So therefore, electrochemical series or reactivity series, you remember, to make a three group out of it. First group, very reactive metals, oxides of, we are talking about oxide to metal, right? Metal oxide to metal. So oxides of very reactive metal, that is potassium, sodium, calcium, magnesium, aluminium. This I will consider as one group. These oxides, these metals are very active and they have a very strong affinity towards oxygen. Therefore these reducing agents will not be able to, you know, break that bond between metal and oxygen. So reducing agent won't work here. Then what is left? Another method is only electrolytic reduction we have to do. Okay, only method from which you can get reactive or highly active metals from their metal oxides is by electrolysis or electrolytic reduction. That too in molten state only or a fused state only. You should not take aqueous. As I told you, in aqueous, if you take, hydrogen will liberate, not the metals. Okay, because these are very highly active metals. Fine. So in group 1, highly reactive metals, you do electrolytic reduction. Why? Because the common reducing agents are not able to remove that force of attraction between the metal and oxygen. Okay. Then coming to least reactive are oxides of silver and mercury, whichever is below copper. Okay, only two we will consider here. Oxides of silver and mercury, like silver oxide, mercury oxide. In this case, you no need to use the reducing agents. You can use, but just by heating them only, you will get the respective metals. Therefore, you don't need to use the reducing agents. Therefore, what we do here, how do you get the silver from silver oxide? Just by heating. So you will get silver plus oxygen and mercury plus oxygen. Okay. Then where do we use these common reducing agents? Moderately active. That is the third group. These four metals come in that: zinc, iron, lead, copper. Okay. In that, zinc is a very special element because iron, lead, copper, you can reduce their oxides by using hydrogen, by using coke, by using carbon monoxide. But zinc is a special case which can be reduced only by the coke. That too at 1400 degrees Celsius. Zinc oxide will be converted to zinc and then carbon will be oxidized to carbon monoxide. But for remaining three, you can use any one. Say for example, iron oxide is there, iron 2 oxide. You can use hydrogen, so you'll get iron plus water. Whatever oxygen is there now, you transfer it to the reducing agent. So FeO is there, C is there, give it to C, CO plus Fe. FeO is there plus CO, give it to CO, you will get CO2 plus Fe. Okay, same thing you can do for lead oxide, PbO, copper oxide, CuO. Here instead of iron, you take lead or copper. Reactions are same. Okay, but what is special case? Zinc. Only with coke, 1400 degrees Celsius. Okay, na? So now if you try to remember them individually, it is very difficult. Therefore, you have to go by the reactivity of the metals. ठीक है ना? Any doubt in this part? Chalo, let's see the question. Aluminium powder is used in thermite welding because, okay, this is a special reaction. We call it as a thermite reaction. Basically, it is used to weld railway tracks. Yes, Tanisha.
It's a strong reducing agent.
Right. So here aluminium powder is used in thermite reaction as it is a strong reducing agent. What is actually this one? Welding the railway tracks. See, railway tracks you can't bring to garage and weld it and go and keep it. You have to weld it there and then only. Okay. For that you have to have a very huge amount of molten iron, which again, if you want to keep heating it, how you will do that? Because your railway tracks will be there, lots of other things will be there surrounding. So they found one easy and simple, not easy, it's very difficult to make this reaction. So here aluminium they will take, which is more reactive metal compared to iron oxide, Fe2O3 you say. Okay, so you understand here, the more reactive metal, this is a displacement reaction, है ना? The more reactive metal can reduce the metal oxide of the less reactive. So aluminum is in the top of the list in the reactivity series. If you see, iron is below, so it can reduce iron oxide to iron and forms Al2O3. This reaction is highly exothermic. Huge amount of energy is released so that the whatever iron is there, that will be in the form of molten state or liquid state. Then that will be, wherever there is a welding process need to be done, there it will be put and it will be welded. Okay, so there will be a proper set of apparatus and all for this, but it is very difficult to carry out there. This kind of reaction will be called as thermite reaction. Means sometimes you can use more active metals to reduce the less reactive metal oxide. Okay, Isha, can you answer this question? Which of the following metallic oxide cannot be reduced by normal reducing agents?
Uh,
It should be highly reactive metal.
Magnesium.
Yeah, magnesium oxide. Okay, potassium, sodium, calcium, magnesium, aluminium. Till aluminium, whatever you have, these oxides cannot be reduced by common reducing agent. But remaining, you can see these can be reduced. Okay, the metal other than aluminium which has a strong affinity for oxygen is. Dhanesh, can you answer this?
Yes. Uh, Magnesium.
Right. Again, the more reactive metals will have strong affinity. Affinity is nothing but attraction. Okay. Uh, Chanvi, can you answer the second one?
Metallic oxide cannot be reduced by normal. Sir, again,
Hmm.
magnesium.
Correct. Magnesium oxide only. Okay. So the next part, these are all the stages. In the refining stage, we don't have anything. Electro refining is there, which we learned yesterday, right? During copper purification. So the same thing. But here they have not given any extra example for that. Okay, whatever four stages are there, we are done with that. Huh? Now we have taken a particular example for extraction of aluminium. Aluminium, okay, from bauxite. Bauxite is a hydrated aluminium oxide. First of all, you should not write incorrect formula. Al2O3 dot 2H2O. Okay. Now, same process we have to follow. Crushing and grinding. So you will take bauxite ore, crush and grind it, make it into fine powder. Second stage, purification or concentration or dressing of the ore. So what we use here, the name of the process is called as Bayer's process. If they ask you name of the process, it is Bayer's process. But which concentration method we are using here? We are using, yes, bleaching or chemical method. Okay. So first stage, it includes three stages. So try to write a flow chart like this. First of all, we will take the bauxite ore and we want to remove the impurities from there. What we do, bauxite ore is amphoteric in nature. Al2O3, aluminum oxide is amphoteric in nature. So to this, we add hot and concentrated NaOH. So what this fellow do? Acid base reaction, right? Amphoteric oxides with a base gives you salt and water. So it will give us soluble salt. The salt which formed is soluble plus water. Along with this, we will have some insoluble impurities. Insoluble impurities. These are specifically called as red mud. Okay, the impurities which are obtained in the first stage, those will be called as red mud. Now you know the impurity is insoluble, whereas your salt is soluble. right? So what salt we get here? Sodium aluminate plus water, है ना? So sodium aluminate is soluble in water. This is insoluble. You will do filtration. Filtration. When you do filtration, what is gone? Impurity is gone, right? As a solid, you will be left with salt, that is NaAlO2. But we can't take it to the next stage. So we have to again get back the solid. Okay. So what they do here, already water is there, they will add excess of water. But in this, the temperature are very important. In the first stage, we do it at around 150 degrees Celsius. Then we reduce the temperature for the second step to 50 degrees Celsius. So you have to cool it to 50 degree, then you add excess of water. So then what happens? The sodium aluminate will get hydrolyzed. It forms back the sodium hydroxide which you used in the stage 1 plus the precipitate of aluminium hydroxide. Aluminium hydroxide is insoluble, it forms a precipitate, whereas sodium hydroxide is soluble, it is an alkali. Again, what do? You do filtration. You know, one is soluble, another one is insoluble. Do filtration, remove the NaOH. You are left with the solid aluminium hydroxide. Then they will heat it simply. What is the temperature? Around 1100 or 1000 degrees Celsius, है ना? So aluminium hydroxide will be heated to a very high temperature. 1100. That we can write 1100. So here we'll get aluminium oxide, and whatever water is there, that will escape as a steam because of high temperature. So finally what we did, we simply converted bauxite Al2O3.2H2O. Finally what you got? Al2O3. So Bayer's process is simply the conversion of bauxite to anhydrous, means it does not contain water, alumina. In simple words, you call it as alumina or aluminium oxide. Yes, Danish. So if you want to convert the hydrated salt to a anhydrous salt, why don't you heat it? The water will go, right? Water will go, but what about the impurities? Impurities will not go, no? So our aim is to remove the impurities. Then what you will do to remove the impurity? Hmm? Therefore, we have to go with all of these three steps instead of one step. Okay, so lots of times they have asked the balanced equations or give reason why we are using hot and concentrated sodium hydroxide, which is also known as caustic soda solution. Okay, this common name also we should know. So when they ask you to write the equation, do not forget to mention the temperature. Okay, these are all balanced equations, stage 1, stage 2, stage 3, step 1, 2, 3. If you understood the flow, then it will become very easy for you. So once again I will explain. Bauxite is amphoteric. So amphoteric के लिए you are adding a base sodium hydroxide. Whatever salt we get, it is soluble in water, and here impurities will be insoluble, which we call as red mud, and that will be removed. Yes, Ayona.
But anyway, is it hot and isn't it a solution just in or is it
No, we
it's
take we will take it because you are heating it 150 degrees Celsius. Now anyway, it is hot. That is one thing. And we take concentrated sodium hydroxide, not the diluted one, because bauxite ore, it has to react, means it should be more in concentration. Okay, so you write hot and concentrated. Same thing we learnt in analytical chemistry, right? It is same reaction. In analytical chemistry, hot and concentrated sodium hydroxide only we used. Okay, so here we remove the impurities by filtration, and the salt which is soluble in water, we reduce the temperature to 50. Then we keep on adding some excess of water till we get some precipitate, white precipitate. That is aluminium hydroxide. Then sodium hydroxide is also formed, but it is soluble in water, that will be removed by the filtration. Aluminium hydroxide, when we heat it to very high temperature like 1000 or 1100 degree Celsius, we get respect to alumina, and water will be escaped. Water will be in the gaseous form. So you will be left with anhydrous alumina. So this is the concentration stage. Next stage will be, okay, before that, let's see some question. What kind of questions they have asked here? Here, see, name the solution used to react with bauxite as a first step to obtain. So this one is nothing but concentrated, hot and concentrated sodium hydroxide solution. Again, write the name. Anyways, don't write the name. Even though it is correct, some people don't accept the answer. Write the equation for the reaction where the aluminum oxide for the electrolytic extraction of aluminum is obtained by heating aluminum hydroxide. So basically, this is the third step where aluminum hydroxide you will take. Under 1100 degrees Celsius is Al2O3 plus 3H2. 2Al, okay, 3H2. Okay, so this will be your balanced equation. State the reason for addition of caustic alkali to bauxite or during purification of bauxite. Who will tell the answer? Please raise hand. Why we are using caustic alkali? Dhruva? So bauxite is amphoteric in nature. So when we add caustic iodide to bauxite, it removes impurities by how? It forms a soluble salt and so impurities will be insoluble. That you have to mention. It forms a soluble salt. That is sodium aluminate if you want to write. And insoluble impurities which are removed by filtration. Okay. So again, give a balanced equation. So don't do mistake. Some people just write Al2O3. No, you have to write Al2O3 dot 2H2 plus NaOH. Always write the condition 150 degrees Celsius. No, not 200. 140 to 150. Okay. Sodium aluminate NaAlO2 plus what you are getting here? Water, because it is a neutralization reaction. Then you balance it. Okay. Now we got first stage crushing, grinding. Okay, that is anyway physical process. Second stage concentration, which we called as Bayer's process. After that, actually we should do roasting or calcination, but here roasting roasting or calcination is skipped. We don't do roasting or calcination because it is already in the oxide state, oxide of aluminium. If it is not oxide, then you do. So therefore it is skipped. Then what is the next stage? Reduction. Now see, aluminium is what kind of element? It is a highly active element, highly reactive element. Aluminium is highly reactive metal. So here it's oxide and has a strong affinity with oxygen. So you can't remove oxygen from aluminium oxide, can't be reduced by using common reducing agents like hydrogen, coke or carbon monoxide. We have to use here electrolytic reduction or electrolysis. So that particular electrolysis process is named as Hall-Herold's process. So understand the story behind it, how this came into existence. Difficulty faced in obtaining aluminium from alumina. So when they were not using that composition of different electrolytes, when they were having only alumina, okay, since we cannot use the aqueous solution, we have to use the molten or fused alumina only. Alumina is having around 2050 degrees Celsius as its melting point. So if you have to carry out this process, you have to continuously maintain the temperature 2050 throughout the process. Okay, so in this what happens, whatever product you are getting, aluminium, which we want to extract, correct? So that aluminium was in the vapor state because of a very high temperature. Then it is very difficult to collect it. Okay, so therefore they have studied different kind of experiments they did. Finally they achieved, to reduce the temperature 2050 to very less, like around 950 degrees Celsius, by using the combination of three different electrolytes: alumina, cryolite, fluorspar, right? So here higher percentage is cryolite, it is 60%, remaining two are 2020. So the ratio, if you see here, alumina is 1, cryolite will be 3, fluorspar will be 1. 1 is to 3 is to 1. Since cryolite is used higher, you can also consider it as a solvent, because these all three are in the fused state, in the liquid state. You know? So more percentage which is there, that will be considered as a solvent, and remaining two you can consider as a solute. So when they used in this ratio, they were able to achieve the melting point as around 950 degrees Celsius. And when they were able to achieve it at this temperature, whatever aluminum we get, that is will be in the form of liquid state, and it is easy to collect the liquid. Okay, so before this process was invented or discovered, aluminum was the costliest metal, but after this it became cheapest metal, and most abundant element is also aluminum. Then why it should be costly? Because of the process from which we are able to extract it, it was costly. But once it became easy, then the aluminum also become, very very cheap.
So, this price and fruits were also as not as conducted today.
Your voice is not so clear. What you're asking?
So, cryolite is large part is also as not as conducted today.
That roles we will see. Hmm, roles we will see. So this is the story behind how now whatever we are using aluminum in everything, even the food is wrapped in aluminum. That is because of this discovery. Okay. State why aluminum is extracted from its oxide by electrolysis, while copper, lead, iron by reducing agents, and mercury and silver by thermal decomposition. Okay. Chanvi, can you tell the answer?
So state why aluminum is extracted from its oxide by electrolysis while copper is so because it's higher, it has a stronger affinity for oxygen and it can't be reduced by like normal reducing agents or by thermal decomposition.
Very good. Compared to copper, lead, iron, which can be reduced by common reducing agent, and mercury and silver, we can simply heat their oxides. Okay.
Yeah.
Come to the process and understand it carefully. Definitely 2 to 3 marks question will be there on this part. So this is the diagram, and this is not done in a small quantity. This is done in a very huge quantity, like tons of kgs. So you can't do this in the lab. Your whole school will be kind of one factory there where they are doing this thing. Okay, so they will do this in a big iron tank. You can see this one. It is iron tank. This iron tank is inside, you know, have gas carbon, or you can call it as a carbon lining, which itself act as a cathode. Carbon lining, which is cathode. Cathode is made up of what? Cathode is made up of gas carbon. Gas carbon is not gaseous carbon. Don't assume that. Gas carbon is one of the allotrope of carbon. Okay, doesn't mean it is in the gaseous state. Okay. And anode also is made up of carbon only, but graphite we use. So when they ask you what is the cathode and anode, you have to write gas carbon and graphite only. Do not write carbon. Okay. Then you can see multiple anodes are used here. Whatever you are see hanging the things, those are graphite rods. And inside it is lined with gas carbon. And you can also observe here a tap which is made to remove the molten aluminium once the reaction is done. You know. Then electrolyte is what? The mixture of alumina, cryolite, fluorspar. 20, 60, 20. In that ratio only we are using. Okay. And then powdered coke is sprinkled over the surface of the electrolyte. So here on top of the electrolyte, they will sprinkle the powdered coke. So many times they have asked a reason for this. The reason is to reduce heat loss by radiation and prevents burning of anode. So you have to write both the points. Even if they ask you for 1 mark, write both the points. Okay. So throughout this, what we keep the temperature 950 degree Celsius throughout the process. Okay. Understood? Any doubt in this part? Powdered coke why we use? Okay. Anode and cathode, what it is made up of.
Sir, iron is also going to be copper. No, this thing, no. Iron can be carbon also. No.
Which one?
Iron.
It is carbon, but not as a pure carbon. You are using one of the allotropes of carbon, that is graphite. You have to write graphite. Okay. So anode should be graphite, cathode should be gas carbon. If they ask you what materials both are made up of, material is same, carbon only, but they are different allotropes of carbon. Okay. So it is same what we learned yesterday. What and all different ions are present. From cryolite, you can see sodium, aluminium, and fluoride. Fluorspar, calcium fluoride, calcium ion, and fluoride ion. Alumina will give you aluminium ion and oxide ion. So in out of these three, calcium is a divalent metal, aluminum is a trivalent metal, sodium is a monovalent. And these two have fluoride also. Only alumina has oxide, but fluoride is very top in the discharge, selective discharge, that list we made. Fluoride is on the top, so it will not get discharged. Preferentially oxide will get discharged. And compared to sodium, calcium and aluminium, so sodium and calcium are above aluminium, therefore aluminium will get discharged preferentially. So basically aluminium and oxide, these two will get discharged. A reaction at the cathode, which is inner carbon lining of the electrolytic cell. See, I told you have to make the number of electrons equal, but when you write initially it will not be equal. I will explain it here. Take the anode reaction first. Anode is positively charged, so anions will move, oxide will move here. It has 2 extra electrons. Because of -2, it will lose that and becomes oxygen atom. Oxygen atom is not stable, so what you will do, you want to get oxygen molecule, so you'll multiply it by 2. So 2 oxide minus lose 4 electrons give you O2. This is anode reaction. Cathode reaction, you come minus. Okay, cations will come here. Cations are Al plus 3. One Al plus 3 can have 3 electrons, so it becomes aluminium atom. Now observe, here 4 electrons, here 3 electrons, so you have to make them equal, because number of electrons at anode should be equal to number of electrons at cathode. So this one you will multiply by 4, right? 4 into 3, 12 you have to make both sides. So this one you will multiply by 3. So 3 into 2, 6 oxide minus 12 electrons gives you 3O2. Here 4 aluminium ions will give you 12 or gain 12 electrons and form 4 aluminium atom. Some of you have written
Yeah.
some some people written 3 here O, then directly 3O or something 3O they are getting, they are converting it to 3O2. How it is getting converted, right? So if you understood what is happening here, then you can no need to remember. Okay, now say they have asked only the reaction at cathode, then you can simply write whatever I have written in yellow color, that much only you can write. Okay, and if they simply ask you what is the reaction at anode, this much only you can write, where you will get oxygen molecule. When you have to make them equal, when they ask you both the reactions, make them equal, 12 electrons, 12 electrons. Okay, don't try to remember, it is not possible, you will definitely do some mistake. But at the anode what happens? At the anode is graphite, correct? Anode is graphite. And what temperature we are keeping here? Usually graphite is inert, it will not react, but because of the 950 degrees Celsius, very high temperature, it will react with the oxygen released at it. So graphite is carbon plus O2, initially forms carbon monoxide, that carbon monoxide further oxidizes to carbon dioxide. Therefore, in this process, we can say that anode disappears. Disappears is nothing but get oxidized because of this. Okay. Therefore, we have to keep on, periodically keep on change the anode as they will be consumed in the process. Okay. So that is one more give reason question. Anode and cathode reaction clear? Anybody has any doubt?
So what?
Any doubt?
Sir, if they ask, give the reaction at anode,
Hmm.
you have to give the last one which you've written.
You can simply just write this 2O2 minus 4 electron O2. That much will be sufficient. Only anode.
Okay.
Huh. When you have to do both, when they ask you to write both. Okay. Let's see different kind of questions they have asked previously. Darshmana, can you answer this question?
A metal present in cryolite other than sodium, aluminium.
Yes. Write the name aluminium. Do not write the symbol. Danish, you have any doubt?
No, sir, I just raised
Anode is oxidized. This is the one I have explained already. So why anode is reacting in this case? Because of the high temperature. That point you remember. If it is normal room temperature, then that anode will not react with oxygen. Okay, we have seen previously where oxygen is being released, there the graphite will not react with oxygen, right? But because of high temperature only, it is getting reacted with this. Therefore, the anode has got to be replaced from time to time as it gets oxidized by the oxygen evolved at the anode. So you have to write this answer. It gets oxidized. Don't write it gets burnt. Okay. Use the scientific terms. It gets oxidized by the oxygen gas evolved at the anode because of higher temperature. Explain why it is preferable to use a number of graphite rods as anode instead of a single electrode during the above electrolysis. Same thing we can explain. Okay, same point. Now let's see the roles of cryolite, fluorspar, and powdered coke. Powdered coke we just explained. 2 points. Reduces heat loss by radiation, prevents the burning of anode. Cryolite, whenever they ask you, write the first point, lowers the fusion temperature. Fusion temperature is nothing but melting point only from 2050 to 950 degrees Celsius. And second point will be it enhances the conductivity. Okay. Fluorspar and cryolite. Imagine, assume that they have asked for 2 marks what is the role of cryolite and fluorspar. तो cryolite के लिए anyway you write first point lowers the fusion temperature from 2050 to 950. Fluorspar के लिए we don't have separate thing, so you can simply write it enhances the conductivity. Okay. Otherwise, only for cryolite, if they ask you, you can write both the points for the same thing. Hmm? And these questions have been repeated many times. Okay. Isha, can you answer the first one?
Mhm. To lower the fusion temperature is that cryolite.
Correct. Write the equation for the reaction that occurs at the cathode during the extraction of aluminium. See here, only cathode reaction have asked. Cathode is cation, cation is aluminium. So 3 electrons will form Al. This much if you write, that will be correct. Along with cryolite and alumina, another substance is added. Name the substance, give one reason. So Dhanish, tell me the answer.
So it is fluorspar, right?
Hmm.
Give one reason for that issue. So it's they both enhance, like they decrease the they decrease the temperature required to melt aluminium from 2050 to 950. It also enhances conductivity of the mixture.
That point you don't write here. That is mainly for cryolite. That reduction in the melting point. Okay. Fluorspar
No,
we can
I think
write.
both these points is fine.
1 point enhance the conductivity for fluorspar. In the electrolysis of alumina using the Hall-Héroult process, the electrolyte is covered with powdered coke. Explain why. Again, the 2 points which we know already. Identify the components of the electrolyte other than pure alumina and the role played by each. So here again cryolite, what is the role? Fluorspar, what is the role? You have to write that. Explain why powdered coke. Again same question. Okay. So this is a flowchart for extraction of aluminium. Again what they do next stage. Now whatever you get after electrolytic reduction, you are getting the aluminium, right, in the pure state. Not pure extractly, it is around 99.8% pure. Then they do again electro refining. So now we don't have it for our syllabus till this much only.
So it's Hooke's process, right?
Hooke's process. Okay. These kind of questions, I think I have given you the same question in the exam also. Okay, I have corrected and sent you. Again, see the role played by each of them. So cryolite lowers the fusion temperature. Sodium hydroxide. This is overall extraction of aluminium. No? Sodium hydroxide where we use in the Bayer's process. So again you have to
Yeah.
explain amphoteric nature, removal of the impurities. Right? Graphite, what is the role? It is anode. That's it.
So it's an inert electrode, right?
But no need to write that. But here it is used as what? In this process. Anode, right? So that will write. Okay. So before we go to the alloys, we'll take 5 minutes break. 11:06 now. Okay. 11:10 we will come back. Let's continue. The last part of the metallurgy chapter, that is alloys. Okay. Before that, we should know what is the meaning of alloy. So if they ask you the definition of alloy, write that it is a homogeneous mixture. This point should be there first. Homogeneous mixture of two or more metals or metal and non-metal. You know, fused in their liquid state. You can't mix two metals in the solid state and get the homogeneous mixture. That is not possible. You have to melt them, then you mix them in a proper ratio, then only you will get the uh, alloy. Okay, so what is the reason for doing alloying? The process of preparing alloy is called as alloying, is to improve the properties. The alloying we do to improve the properties of elements. Okay, like iron, it gets corroded very easily. So if you make it into steel, that property will be reduced. So it becomes better, right? Like that. Aluminium may be lightweight, all right? To make it even more stronger, we mix some magnesium with it, right? So we are enhancing the property. In some cases, we want to reduce the melting point of some metal, like in case of solder. So we reduce the melting point and that will be utilized for soldering purposes. So to serve different kind of purposes, we will mix two different kinds of elements. Okay, so for our syllabus, we have duralumin, stainless steel, brass, bronze, and solder. These five. Okay, so coming to duralumin, as the name itself tells, alumin means it is a main element in this alloy will be aluminium. So I think I told you the technique to remember. Alku Maggie Man. You can remember Alku Maggie Man. What is this Alku Maggie Man? Aluminium, copper, magnesium, and manganese. Okay. And that too in the decreasing order of their percentage. Highest will be aluminium, then copper, magnesium, and manganese are equal. No need to remember these percentages, but you should know which is the main metal when they ask you. It will be the one which is in higher percentage, right? So that is aluminium. So the properties of aluminium, here these 2 points you read. Aluminium imparts lightness. In this duralumin, aluminium's role is it imparts lightness, whereas magnesium imparts strength. So this is lightweight as well as strong. So because of that, main use of the duralumin is to make the bodies of aircraft. Okay, or light tools and pressure cooker also. Mainly these are the things. Aircraft, buses, tube trains, all the main bodies of some vehicles. Coming to second part, iron, main ore of sorry, not ore, the alloy of iron is stainless steel. So you have again four elements in that: iron, chromium, nickel, and carbon, right? So remember this like this: Facronic, okay, Facronic, iron, chromium, nickel, carbon. That will help you. So higher percentage is iron, so main element will be iron. And if they ask you which is the non-metal in this, that is carbon, the non-metal present in stainless steel. So how it improves the property? It resists corrosion. It makes the iron lustrous, okay, hard and resistant to acids and alkalis. In this case, nickel and chromium, they impart luster, whereas carbon imparts hardness. So those are the roles of the elements. Main use of this will be surgical instruments and in household utensils, okay, or cutleries. Some other uses, ornamental pieces, and also they have given here. But main uses we will try to remember how much is possible. Okay, remaining things don't worry here. Coming to the alloy of zinc and copper. See, zinc and copper together, it has two ores, two alloys, not ores. Okay, brass and bronze. Again, many people have confusion which is brass and bronze. Okay, brass has only zinc and copper, whereas bronze has zinc, copper, as well as tin. Zinc will be in very less quantity. In both the cases, which is the main metal? Copper. Copper and copper. Zinc are there again, but in second one you will have tin also in bronze. Okay. So brass main uses will be like decorative purpose, screws and handles, musical instruments. But sometimes in Greenwood High they may also, parts of watches, these things they may also give. Electrical goods, this one thing you understand, no? Electrical goods, that there also we use brass. Do not write solder for this. Okay, solder is for soldering purpose only, not for electrical goods. Bronze, mainly medals, statues, these things we know, coins. Okay, some bronze utensils are also there. Coming to last, lead. The lead, the alloy will be solder, which is also called as fuse metal. So I remember it like this: solder, S for tin, Sn, Ld for lead, Pb. So it's mainly two elements. Both of them are 50-50 only. Okay, lead and tin, both are 50-50. So here they have low melting point, 180 degrees Celsius. Which one helps in that? Tin. Tin lowers the melting point to 180 degrees Celsius. Main use will be soldering purposes. Okay. So solder, anyway, easily you can identify soldering purpose. If they give you fuse metal, then that is also same, solder only. Okay. So these are 5 alloys and their elements. Mainly, lots of time they have asked what are the elements of this alloy. Okay. Or sometimes to match the uses part with that. Dhanesh, tell me.
So they won't ask the percentage, sir.
No, percentages they will not ask. Okay. Huh.
Sir,
Yes, Rishi.
so the main elements they'll ask is only duralumin and stainless steel, no?
Why? Why can't they ask
Like,
you other things? If they ask you, then you just write copper. For zinc, for brass and bronze, it is copper only. For solder, it is anyway 50-50.
oh,
Hmm. Okay. Huh. So here, hmm. Isha, can you tell the answer for this? The two main metals in bronze are.
Um, copper and tin.
Very good. Copper and tin. It has copper, tin, and zinc also, but zinc is very less quantity. Okay. Uh, Next one, Iona. This is not an alloy of copper.
Solder.
Very good. Remaining all have copper in it. Stainless steel, that also does not contain copper. Okay. Name the alloy used for the following purposes. Electrical circuits. Electrical goods are different. Electrical circuits may we do soldering. So we have to write here solder. If it is goods, then it is brass. Okay. Medals के लिए bronze. Parts of watches we just seen, it is brass. Surgical instruments के लिए we have stainless steel.
stainless steel.
Aircraft के लिए
Duralumin.
duraluminium. Okay. The metals zinc and tin are present. Just now we have seen it is in bronze. The reason for using aluminium in the alloy duralumin is Dhruva, can you tell the answer? Dhruva, are you there?
Yeah, sir, talk on mute.
Huh.
Sir, it brings lightness.
Aluminium brings lightness. Okay. Brass is an alloy of Chanvi.
Sure, it's an alloy of copper and zinc.
Very good. The main component, see here, the main component, main metal. Here you can see brass and bronze, everything is asked. For both of them, copper and copper. Here it is aluminium. But write the names, not the symbols. The following questions relate to extraction of aluminium. Name the other aluminium containing compound added to alumina and state its significance. Okay, Ruhani, what is that? Name the other aluminium. Hmm?
Oxygen.
No, no. Name the other aluminium containing compound added to aluminum.
Oh, added to add.
Hmm.
I'm
अरे
not getting.
okay. Cryolite है ना Na3Al6 extraction of aluminium part. Okay. Its significance is lowers the fusion temperature. Okay, give the equation for the reaction that takes place at the cathode. Done. Explain why it is necessary to. Okay, this is also explained. Okay, here you can see match the properties. So Vanishika, can you tell the answer for the first one?
Yes, I don't have anything.
First one.
So it is stronger than aluminum, it is lighter in weight, used for making batteries.
No, the alloy contains copper and zinc, is hard, silvery, used in decorative
Oh,
articles.
yeah, I was waiting for that. Uh,
Okay, you have matched this one, ना?
yeah, okay, fine. Now,
ठीक है, ठीक है, ठीक है. Second के लिए A. Okay. Copper and zinc only if it is there, and decorative it is brass. है ना? Lustrous, hard, corrosion resistant, surgical instruments के लिए stainless steel. D. Lowers the melting point of alloy use soldering purpose, solders. So A, B, C is left. That will be here. Okay, from this list we have to choose the a black powdery substance used in the reduction of zinc oxide during its extraction. Okay, Rishi, tell me.
Uh, Rusting coke.
Hmm. Can you tell the equation?
Uh,
Zinc oxide formula is what?
that I know.
Coke.
C.
What happens? Reduction means
Rusting displacement.
product. Tell me.
Will be Zn plus carbon monoxide.
Hmm. So for this we keep the temperature 1400 degrees Celsius. Okay. A substance is an alloy of zinc, copper, and tin that will be bronze. Okay. Answer the following. ठीक है, these questions will name a metal which is found abundant. Okay, this one is not required now. What is the difference? Calcination, roasting. Name the process used.
That's not aluminium, right?
Huh. C. Name the process used for the enrichment of sulfide ore. Yes, what is this one? Tanish, tell me.
In the so this is transportation.
Right, froth flotation. Chemical formula of one main ore of iron and aluminium. Okay, you can write Fe2O3 dot 3H2O, right? And for aluminium, Al2O3 dot 2H2. Or you can write any ore of iron. Hmm. Write the, but they have asked a main ore, no? Okay. Write the constituents of electrolyte for the extraction of aluminium. Constituents of electrolyte is alumina, cryolite, fluorspar. मेन कॉन्स्टेंट अगेन ड्यूराल्यूमिनियम के लिए aluminium, स्टेनलेस स्टील के लिए आयरन, ब्रास के लिए कॉपर. See, 3 marks or 2 marks they have asked many times. ठीक है, this is not valid now. The last question here, they have given a picture and asked this is used in the extraction of aluminium, है ना? So what is the substance of which the electrodes A and B are made up of? So what do you write here? Don't take risk, right? A is negative cathode, na? So cathode is made up of what? Gas carbon. Gas carbon.
Gas carbon.
Yes. and anode. B is anode
Yeah,
connected to positive, graphite.
graphite.
Then you write, after this you write, both are made up of carbon. ठीक है? Then they will not have any chance to cut. At which electrode is the aluminium formed? Aluminium is cation, cathode के लिए it will go, so A. What are the two aluminium compounds in the electrolyte? So name you have to write again, alumina and cryolite. Why is it necessary for electrode B to be continuously replaced? Electrode B is graphite, so we know it is get oxidized with the oxygen evolved, hence it has to be continuously replaced. Okay, so that is the last question.